So, what exactly is route redistribution? Route redistribution is the process of allowing different routing protocols like OSPF and EIGRP to share route information with each other. In other words, it acts as a translator between two routing domains that normally wouldn't communicate directly. For example, routes learned by OSPF can be shared with EIGRP and vice versa, so both networks know how to reach each other's destinations. Why use route redistribution? In some networks, you might have multiple routing protocols running at the same time. For example, OSPF in one area and EIGRP in another. Normally, these protocols don't talk to each other by default. Route redistribution allows them to share routes so one routing domain can learn about networks from another. This is especially useful during network migrations, mergers, or when integrating different vendors or legacy systems. It basically acts as a bridge that keeps communication flowing smoothly between different routing environments. How is route redistribution used? It's configured on a router that runs both routing protocols. For example, a router running OSPF and EIGRP. Using the redistribute command, we can tell one protocol to share its learned routes with the other. For instance, redistribute OSPF 1 metric 10,000 10 255 1 1500 allows OSPF routes to be advertised into EIGRP using EIGRP's metric format. The key is to understand what each protocol uses as a metric. OSPF uses cost, while EIGRP uses bandwidth, delay, reliability, load, and MTU. This helps both protocols make smart routing decisions while avoiding loops or inconsistencies. Now, let's look at some of the key features of route redistribution. First, it supports route maps, distribute lists, and tags. These are all tools you can use to control which routes get redistributed and how they're handled. Second, redistribution lets you filter specific routes, so you're not flooding your routing table with unnecessary information. You decide exactly what gets shared. And finally, it definitely adds flexibility to your network, but that flexibility also introduces complexity. So while it's powerful, you want to use it carefully and plan your redistribution strategy ahead of time. Before we look at an example, let's go over a few key terms you'll need to understand for route redistribution. First is the seed metric. This is the initial metric that gets assigned to redistributed routes when they come into another protocol. For example, when OSPF routes are brought into EIGRP, we need to give them an EIGRP style metric to make them compatible. Next is the external route. This simply means a route that was learned from another routing domain, not the one that originated within the protocol itself. Then we have the route map. This acts like a filter or translator, letting you decide which routes to redistribute and even modify their attributes as they move between protocols. And finally, tagging. Route tags are used to mark redistributed routes so that they can be identified later, helping prevent routing loops or confusion when routes move between multiple domains. Now let's look at a quick example of how route redistribution actually works. On this router, I'm redistributing OSPF into EIGRP using this command. Redistribute OSPF 1 metric 10,000 10 255 1 1500. This command lets routes learned by OSPF be advertised inside EIGRP. You'll often see something similar when two different routing domains need to communicate. And this is exactly how the router shares those learned networks between both protocols. Next, let's break this command down so you can understand exactly what each part means. Alright, let's decode this line step by step. First, redistribute tells the router that we're about to take routes learned from another protocol and inject them into the current one. After that, we have metric followed by 5 values. These numbers are specific to EIGRP and represents its metric components. The first number, 10,000, represents the bandwidth. The second, 10, is the delay. The third, 255, is the reliability, with 255 being 100% reliable. The fourth, 1, stands for load. And the last one, 1500, is the MTU, or maximum transmission unit size. Together, these values tell EIGRP how to calculate the metric for routes that came from OSPF. Essentially, this command translates OSPF routes into EIGRP's language, letting both protocols share routes seamlessly. Now, we'll take this command and implement it in Packet Tracer to see how it works live. We'll start by entering EIGRP and redistributing OSPF inside of EIGRP. Next, we'll enter OSPF and redistribute EIGRP routes to OSPF's metric. Now let's check R3's routing table. We see the legend O, E2, meaning our route redistribution successfully worked.